Let me start by introducing myself. My name is Daniel, like I said, the Endo Daniel. Jesus. I hope everyone can hear me. Can hear me clearly, right? Can anyone hear me?
Yeah, I can hear you, Mr. Daniel.
Okay.
Yeah.
Okay, so my name is Beyond Daniel. Yes. And I'm a mobile developer, like I said. I'm a mobile developer. I prefer calling me a mobile developer. I develop mobile apps basically with
You
Flutter. So,
can go ahead.
and I can do Python development, and I've been using AI for some time for different products. And so when I saw the invitation for this topic, though I wasn't prepared for any speaking stuff also, but it came out of kind of like a rush. But I don't want to use the word rush. But, but I'm here. That is a major change. So let's start with generative AI. I'll be sharing my screen. I'll be sharing my screen. Okay. This is it. Oh, so everyone can see my screen, right?
Yes, I can see it.
Okay. Let me go with right. So when we talk about generative AI, when we talk about generative AI, generative AI is just machine learning. Let's take it out. It's machine learning algorithm, but in this case, it's neural networks. Machine learning that uses neural networks. There are several machine learning algorithms, but generative AI utilizes neural network techniques. Like when we say neural network, the first thing that may come to our minds could be the brain. That was the first picture that came to my mind when I heard about neural networks. And so neural networks actually like they have nodes and points. So there are different ways neural networks learn, just like the human brain learns. Even so, neural networks uses that aspect perspective of the brain to learn from new data. So generative AI learns from the input data, whatever the input may be. It could be a text, it could be songs, music. It can even generate videos, images, and even codes. So depending on the training data, the generative AI learns from the training data, and the aim of the learning is so that it can generate something that is similar to the data it actually learned from. So assuming it learned from an image data, the expected output is another image similar to the one it saw. So we have seen several generative, let me not run fast. Okay. We go slide by slide. Okay. So we have different types of generative model. We have the GANs, we have the variational order encoders, and we have transformers. So all of them have their different areas of strength. Some can be good for one thing, and others will be good for another thing. So generative adversarial networks, the GANs, they are basically they are basically networks that have, let me come this way. So GANs uses two neural networks, one for training, one for generating output data. After it receives the input data, learn from the input data, and once it generating the output data, that is what the user actually wants. Assuming we train it with one image of a phone. Let's say we've given this generative AI or the model several different phones. We've given it 1,000 phones. So we are asking it to now generate another phone. So what these particular networks do is this. They will generate the phone because they have two networks. They have the discriminator and they have also the generator. So the generative part of the GANs will generate a new phone, but the other part of it, which is the discriminator, they will have to like, okay, distinguish it from real data. So from that process, if it is not so much like a real data, it will have to kind of learn. we have something called the reinforcement learning. Reinforcement learning try to like mimic mimic exactly what something is. So it starts by correcting itself, correcting itself. If it is not appropriate with what it was expecting, it will correct itself and come back to like get the result so closer to what it was expecting. So the same way with these GANs. So GANs actually learn to generate the output data. Then the discriminator of GAN, the next part of GAN, will have to like, okay, what you have generated is close enough to human, to the natural. So if it is not close enough, it will have to regenerate and over again. So in that process, it will generate something that we may not be able to differentiate from human perspective, what humans could have done. So another one is we have the variational autoencoders. So these ones, they have the encoder, they are in two forms too. They have the encoder and the decoder. Can anyone hear me?
Yes, I can hear you.
It's as if I'm talking to myself. I don't know if anyone wants to ask
What
any
you do for me
question.
is just raise
Okay.
your volume a little higher. Try.
Okay. I thought I was loud enough. Okay, but I will try harder. So we have the variational autoencoders. So this particular network, generative AI or model, they they have the encoder and the decoder aspect of it. So the encoder receives input data from the network, and it learns to like kind of map that input data to a latent space. So in the latent space is just like simply, to put it simply, it's like the real data you imputed being mapped to some another state that is kind of compressed data, meaning the difference is between the data, that is the outliers. Okay, let me use the word dimensionality. It reduces the dimension between the real data so that it can actually learn faster. So that is the encoder. So once the encoder maps to that latent space, it will have to like the decoder will map from that latent space to another to actually generate an output data. So in the case of let's say music, someone give the generative model, this model, a music or a song, and it will learn from that song, map that song to a latent space. Then the decoder will now generate another new song that is kind of related to the input song in that way. So that is just the variation from the input data and the output data by the encoder and the decoder. Then another models we have are the transformer models. So the transformer models are basically used for text generation, like kind of natural language processing, like in the large language models we have been seeing that GPT, we have Bard, we have Gemini. Gemini now is taking over from Bard. And how many of us know that Gemini has been taking over? Sorry, has taken over Bard.
Oh, yeah, I had the announcement.
Yeah, they've already started. So we don't have Bard anymore. You have Gemini instead of that. So Bard and all the other large language models use this technology like the transformers. So they are used to generate text. The basic thing in transformers is that transformers learns to like there is something called self-attention in transformers. So in the self-attention aspect of it, it tries to understand a word and the relationship with other words in that particular sentence. That is the basic thing with transformer. So it generates that relationship with words. It will pick a word in a sentence, and no matter where the other words are, it will try to learn the relationship between one word and other words in that particular sentence. So those are transformers for you. Then, so the three basic types of models we have are the grams, we have the variational operant products, and we have the transformers or transformer-based model. There are several of them. So, but though we also have other ones, but these are the ones we'll be looking at for the sake of this. So, what are some use cases of these generative models. What can we do with them? We can use them to like drug discovery, new drugs, assuming you just come to a particular, maybe there is this kind of disease that has no cure. Let's take HIV, but I don't want to mention it. Let's use it for example. HIV. We have HIV that no human has been able to discover a cure for it. So assuming this technology, this generative model, this technology grows, and over the years it learns, so it becomes so vast that once you give you the disease, the structure of HIV, then the vast knowledge of it, which based on past experiences and everything it has learned from these autoencoders, or sorry, these generative models can generate a perfect cure for HIV, something that maybe a mere human couldn't have thought of. Those are one powerful aspects of these generative models. And we can have personalized models, personalized learning, like in the Duolingo language learning app. So this one is tailored for individuals. Like, okay, you come to a system, or to the system based on your performance, or based on what you have done before, or based on your perspective of maybe a particular subject. It will relate to you just what you need to know, not based on other students. This could be better than just a teacher in a class that maybe, okay, they are taking everybody the same way. But in this case of generative model, it will just take you as you are, not differentiating you from yourself or rather you. So this is one aspect of it. Then we also have music generation. We have music generation. We have content creation. Content creation for the videos, for the images, for the text. So the example we have here is the DAW E. And for music generation, we have AMPA music. All these are AI that generates different sorts. Like the music generation, we have the AMPA music that generates music. And we also have the DAW for content creation, images, and the rest. Then code generation, we have several of us, if you have been, almost anybody that is writing code must have heard of GitHub Copilot. So Copilot helps you to like suggest lines of code for you, and you can write an entire code function or talk about anything for you. Then we have scientific research. This is by Google DeepMind's AlphaFold. I can help you understand then fashion design. And the use cases just goes on and on. We are not limited to just this one. We have several other use cases of generative AI. So now, one, one thing I wanted to say is this: we cannot all develop the generative models from scratch. We cannot all develop them from scratch. Though we might have the idea, we might have the maybe the knowledge or even the technical know-how to develop them. We can write the code, we can even have everything, but individuals don't necessarily have the resources to train the generative models. According to Google, Google was talking about is a large language model, is LLM, as having about 7 point something million parameters or so, or even more. So that will take for my system, it will take a year maybe or more to train, just to train one model. So we as individuals, or just we don't have the resources to train these large language models. And a single person might not be able to train them. So what is the other way? If this stuff is so important, what is another way we can make use of it? So these tech giants like Google, Facebook, and the rest, they've provided ways and APIs to support developers so that they can be able to use this technology in their own apps, their websites, in their products. So for Google have been working on this, and Vertex AI is Google platform where you can make use of to integrate this particular technology into our different products. Personally, for me, I've been eyeing Gemini for my personal product and this Vertex AI for image generation and for image analysis. So these companies, they are helping developers to carry on the progress of generative AI into our own apps. And Google provides things like the Google Cloud and even Firebase for app developers. Firebase, where they can make use of all of these, their progresses in AI and generative AI to be specific. And another company is Microsoft. Microsoft also partners with OpenAI. Most of what Microsoft does, OpenAI does is actually from Microsoft. So Microsoft, they have their Azure development, Azure as their cloud platform, so that we can users or developers can integrate their products into their different um, applications or websites. Amazon, one of the most ones I love most, one of them that I love most is this AWS, that is Amazon Web Services. So AWS have several stuff that we can, developers can use to actually improve their apps and their websites or any product they want to like, they are looking at to develop. Like this Amazon Translate, you can actually make use of it to translate your text or from assuming you want to build a social network and you are expecting users from all over the world. So you can actually make use of Amazon Translate to translate from one language to another. Then Amazon Text Extract, even SageMaker also. So all these ones are, we as developers might not necessarily have to train these things from the start because these guys, they have the technology, they have the resources to actually host these stuff and we just maybe connect to them through an API or one thing. So Amazon Translate, Amazon SageMaker, for training and deploying for some generative models. You can make this one. Amazon actually hosts tutorials on sometimes Udacity and even other places like you can learn more of Amazon on even on Udemy also. We have the text extract and we also have Amazon Code Whisperer. This one is just like code, GitHub Copilot, where you can use it to like help you in developing some code. Then we have OpenAI. OpenAI, apart from just being part of Microsoft, OpenAI also develops their products like the OpenAI API. You can connect with it to integrate OpenAI products and resources into your personal apps and website. Another group is the Facebook. Facebook have PyTorch Hub where you can share and even also host your own Python developed models and other AI related resources and connect to it in your app. So, but no matter how good something is, there are also disadvantages. Like I was thinking of something this just last week. I said I want to train a particular I'm working on a particular app. So I was intending to train. It's actually a church app that was intending to train the pastors, but get the pastor's messages, train his voice, and kind of put it into the app, integrate it into the app so that if they are reading there are some kind of things that they want to read. So it will be actually the pastor's voice and the pastor's information, everything reading that particular script or sentence out. But after thinking of that, the next thing I thought of was, okay, that will not be too nice because others might take advantage of that and replicate that and try to share maybe misinformation, kind of write bad things and let that voice read it out. And that could be implicating to the person. So deep fakes and misinformation could actually be a disadvantage of this kind of generative models in the sense that someone can copy your voice or your face or something about you and just spread it on the internet. Assuming you have 1,000 or let's say 100 videos and pictures on Facebook. Someone just copy those, download those pictures and train a model with this particular technology and spread it around on the internet. That could cause damage either to your name or something about you. And we have the bias and fairness, and we also have job displacement. This one has been the particular fear of most of us, job displacement. This may actually cause people to leave their jobs. But it's happening. I saw another news that says Google was trying to like drop down some 32,000 workers or so from its company from around the world. So what are the potentials of this? We have personalized experiences, we have scientific breakthroughs, we have augmented creativity, amongst others. So imagine AI tailoring everything from healthcare to other aspects of our daily living based on your preferences. Maybe what based on what you like, exactly based on what you like. So those are personalized experiences, bringing you maybe okay. We know. Let me not go into that. We know what we mean by personalized experience and scientific breakthroughs, and we have augmented creativity. Those are potentials of this technology as well. So I have some links that I would want to share, but they are not here on this particular slide. So that is it. If there is any question anyone wants to ask.
Okay. Thank you very much for that, Mr. Daniel. It was so informative. We learned a lot, particularly. Personally, I've come to hear one or two new terms. Um, Before I go on to the next speaker, I will quickly want to say that thank you very much that despite the short information, short time awareness, you'll be able to make it this much. Like your content is loaded even than I thought it would be. Thank you very much. Right now, I want to call on our second speaker for today, Mr. Kodri Adekunle Ladejo. Please, Mr. Adekunle, you can have it from here.
Yeah. Good afternoon. Good afternoon.
Yeah.
So my name is Kolawole.
Kolawole Ladejo. Okay.
Good afternoon, everyone. Once again, my name is Kolawole Oladejo. I'm a member of Python Data Team Content Center. I've been working on Python for more than 2 years. Recently, I joined a because remember last year, I was from today I'm here to present generative artificial intelligence. Right now, I want to share my screen. Permission to share my screen, just I can see host disabled participants screen. Can you hear me, Justin?
Yes, I can hear you. You said?
I'm only to share my screen here. Can you share this?
Okay. You go to share screen. Can you see that on your screen?
It's telling me host admin, host
Okay,
disabled.
okay. Permission. Let me see something. I don't know why. So, Mr. Daniel just share the screen. Okay.
Okay.
Yeah, yeah, you can go ahead.
Okay. Generative artificial intelligence. Uh, artificial intelligence is, I mean, is the same thing as generative model. How does this happen to present today? Introduction, how does it work? Machine learning, the benefits of machine learning, the limitation, example, cases, and its features. That's the content I'm here to present. We are talking about generative model. Generative artificial intelligence. It's a type of artificial intelligence technology. We also call it a generative model in the sense that what I mean by artificial intelligence. Artificial intelligence is a branch of computer science that encompasses all machine learning model. Machine learning model. Under machine learning model, we have a supervised learning. In case of this one, generative artificial intelligence is a model on its own under artificial intelligence. So artificial intelligence is a technology that can, uh, generative artificial intelligence is a type of artificial intelligence that is capable to produce a, a new content by supplying the model with a trained data set, particularly a large data set. It is capable of producing similar content like text, image, audio, and synthetic data, for instance, artificial data. Those are the data that we can get from like robots, like chatbots, which are the data we can get. This generative artificial intelligence, it has been existing. No, it's not a new invention. It was introduced in 1960 chatbots, but it came to limelight recently, like in the 2014, like the creating a model called which is generative adversarial networks. It's, uh, that was the model that was introduced recently. Also known as refers to a class of artificial intelligence model and systems that have the ability to develop their. Unlike the discriminative model, that's what we have like the discriminative model. We have different kind of model. We have a classifier model, like the basic model. Those model, their focus is to classify or predict the existing data. Unlike this generative model. Generative model is meant to produce images or text. While the discriminative model, they are meant to classify data based on the on the label on the label given. The next slide. How does this thing work? Generative artificial model works by generating a large data set of a large data set. You gather a large data set, for instance, like text or image. You gather a large data set of text or images, audio. We change the data set, change the data set. After training the data set, we move to the stage of learning. From this stage, learning, learning simply means once we gather a lot of data sets, our data set comprises of many features. For instance, text, we have like a category, we have a numerical and all that the don't have a features a, like our target. Our target, that's the target you want to predict. For instance, now you want to generate a new set of tests. So we make our model to understand each feature of the data set. By making the model to learn from the data set. After making the model to learn this, we move to generating new data. The train model we already trained, it can now be used to generate the test that is similar to the input data we generated. It will be similar, but not really identical. The test that we generated will be human-like test, very similar to the input data taken to the model, but not really identical. What that means by not really identical? For like a father and son, they are similar in character, so they are not alike. That's exactly what is happening here. So after generating the data set, that is text, we need to evaluate the generated text what to release. And but generating it may be a little bit challenge because of the task involved, like uh, the data generated, they are human-like tests, and it will be difficult to differentiate it from the original data was equal to the model. Now, in order to evaluate the model very well, if it is uh, if it can pass a quality as well, if it can pass quality as well, we can use some metrics like a perceptual and quantitative metrics. This perceptual, what do I mean by perceptual? Perceptual in the sense that you can use a human judgment to evaluate our metrics. In the sense that you can use that model to simulate the conversation with human user. If the conversation is coherent and the realism of the uh, conversation, like this is what I'm saying. You can the head of your UPA, they have what is called Leo. Leo is an artificial intelligence. It can chat with you as if you are chatting with human. It's a kind of chatbot. So if you want to evaluate this kind of model now, you can use human judgment to evaluate it. And also, we can also use a quantitative metrics to evaluate this. If you want to use the quantitative metric, you can use a perplexity. But this perplexity is meant for image generation. The image generated from our model, we want to evaluate it. We want to know the quality of the image and this perplexity. Perplexity is a digit. Quantitative, you have a 0 and 1. It has a zero complexity. Zero complexity means it has better performance. Our models have better performance. But if it has 1, that means the performance, the quality is very, very poor. That's how we evaluate image coming out from the model. Then we have another one below. That's a bilingual evaluation of the study. It's another metric that can be used to evaluate our model. So this one you have the 0 and 1, 1, 1, 2. But if the model has a 0, that means it's very poor. They are opposite to each other. This one will have as 1. That means that's that's better performance. So that's how we evaluate that. But in case of you want to use a blue, it can be very judgmental in case of human perception because of some languages barrier. Like English, we have a idiomatic expression in English language. We want to evaluate our model based on the English that we can interpret. Like English, you have a idiomatic expression. For instance, now let me say one idiomatic expression like kick the bucket now. Kick the bucket in English. may not mean the same thing, may not give the same meaning as kick the bucket in Japanese language. So if we want to evaluate our model based on this translation, it may be a little bit confusing in the sense that the model we understand that the kick the bucket, if we interpret it, we may not be in another language. So we want to judge it now. Instead of actually it performed better, but the blow will give 0, which is poor performance. So that's the disadvantage of using this blow. And another one, if you want to evaluate like grammatical or grammatical order, like we have a subject, we have verb and object. The order in English language may not mean, I'm sorry, the same meaning in the other language like Japanese. So those are the short fun on this evaluation using the law. So we after evaluating our model, we need a feedback. The result gotten from the evaluation will now be used to improve and to retrain our model if the evaluation is negative or vice versa. So we may now use it to retrain our model. So we have a machine learning model. Machine learning model is, I said earlier, it's a branch of it's a branch under artificial intelligence. So machine learning model, they are algorithm or mathematical representation. They are able to learn features and patterns that was put at input in order to generate or predict to predict the outcome or to give decision. Therefore, generative model encompasses various types of machine learning approaches, including supervised learning, unsupervised, semi-supervised, and reinforcement learning. This kind of supervised learning, supervised learning. What do I mean by supervised learning? Supervised learning is said that we train data based on labeled data. When we have our data now, we have different features on our data. We have a dependent variable and dependent variable. That's our target variable. The target the variable that we want to predict. So in that case, our data has been labeled. So we now train our machine, our model to learn from from the labeled data. So that kind of learning, that kind of machine is called supervised. But unsupervised, you have a data or you have raw data. The data has not been labeled. They are unlabeled. Just give the machine the data. It's not left for the machine to decide based on the raw data given to it. We have a semi-supervised. It's combined with the two, supervised and unsupervised. And in case of reinforcement learning, this one is we are more familiar with this one. Kind of when we train an agent, let's say we have an agent, now train the agent to the design. Now the agent now based on reward, if it is successful, you give job. If it's not successful, you give up the penalty. Like let me show you a real life example now. Let's say we have an autonomous vehicle now. Autonomous vehicle. Autonomous vehicle. We have a car that nobody is driving. Nobody is driving the car. You just put the car on the road. The car is moving, and the car arrives safely to its destination without being driven. So that kind of learning is called reinforcement learning. The agent there is the vehicle particularly. Is the vehicle. Now the environment. We train the machine, we train the agent to adapt with the environment. That environment is at the pothole on the road, also the traffic, the bridges, and is able to adapt both the depots. He knows how to match break when you enter traffic. He knows everything, and he arrive, and the vehicle arrive safely to the destination. So the destination is the target. That's our decision. You make decisions successfully. That kind of learning is called reinforcement learning. Now we have several type of machine learning models. We have generative adversarial networks. This kind of networks, which is very popular. That's two networks. It uses two networks. Yes, it uses a generator and discriminator. What is the function of generators is just that it's learned. The generator learns how to generate the realistic data from the sample. Inside our data, there are some realistic data. If you know how to generate them. Now, the function of discriminator now here is to differentiate between the realistic data generated and the sample and the entire sample data. That's the function of this machine learning. And the second one, the solutional autoencoder. This one is a probabilistic generative model. It also consists of two networks. That's encoder and decoder. Because the function of encoder is that it's what with it takes the input data, our large data sets, that's the input data, it take them, it will now convert them to a latent space, let me just put it simply. If you convert it to a format, that is, let's say binary format, the format that machine learning can understand, that's the binary format. You take the encode it. So after encoding it, the coder now take the formatted data, the formatted binary data, you take it then and not translate it to the format that human can understand. That is the text. That's the text, audio, video that we understand. That's the function of this one. The third one is auto-regressive model. This model generates data one after the other based on the previously generated element, based on the previously learned inputs. That's what this one's the transformer. This one is uses the the natural language processing tools for especially for text generation, image generation. For for but for this one, we are very familiar with the chat GPT. That one is for text generation. Text generation. Then we have another one for image generation. That's the example of that one is Dahi. That one is meant for generating arts. It's meant for generating images. And we have another one, BERT, bidirectional encoder for representational transformer. They are all used for text generation and image generation. Now move to the advantage, the benefit of this artificial generative model. It's automate the manual process of writing content. In the sense that we leverage on this model. You can leverage on this artificial generative model to generate content automatically instead of writing it manually. In order not to waste time and energy, so we can generate content automatically by the use of, let's say, ChatGPT. Then it will reduce the effort of responding to mail. You can leverage on artificial intelligence and generative artificial intelligence. Can leverage on it. It has what we call AI-driven email. This one it has the capability of classifying email based on the classifying email based on the content of the mail, the receivers and the sender. So it's capable of responding to them based on the trained templates, on based on the pre-trained data that has been given to the model to learn from. So as a result, it's able to generate the response to the mail based on the pretrained template that have been according to the content of the mail. Also, it has the ability to put the response to specific technical queries. In this case, where it's able to generate technical queries by supplying some input, relevant input to the machine that has been trained on it. Like for instance, now let me show you where we have a code now. Maybe you having bugs that you are unable to solve. You can analyze it. What do you want? Like for instance, analyze ChatGPT. You can supply all your problem you are facing, what you are expecting to resolve. It will analyze everything to solve your technical issue. Likewise, we have a creating realistic representation of people. It is able to generate representation of people, like image that you are like resemblance of people that you will be unable to differentiate between the two of them. So it relieves the pressure of of getting of getting of expensive tools of getting expensive tools to get all these things done. Then lastly, it's really the cost associated with creation, content creation. In this case, what I mean by this, uh, for instance, now we want to design image, like let me say architectural images. You can do this too by leveraging on generative artificial intelligence. If we generate this thing, that's a template that has been trained on that has been trained. So if you generate this thing at low cost, it reduces the cost of getting labor, getting materials. So we can do this thing automatically at our easiest time. So it's very easy to do this thing here. Generating AI model. Now we have a limitation. Everything that has good good side, surely must have a bad side. The bad side of this is yeah, like we have a insufficient or biased training data if poor performance of the model. But now our model, we need a large data set to train our data to train our model so as to achieve better performance. So if we now supply a little data set to our model, it will definitely be a poor result. So we have a Digo. We have Digo. That is a garbage in, garbage out. That's what we have. Whatever we put, that's the what we give out. So we need a large data set to train our model in order to expect better performance. So if we now supply little input, we need a poor performance. Like also does not always identify the content sort of the content. So then in this case, let's say for instance now the ChatGPT. If you need anything from ChatGPT, it just give you the content. It never tell you the source, the author of the author of it. That's just the advantage of using it. It's not giving the author that wrote what he gave you. A realistic sounding content make it harder to identify the inaccurate information. In this case, this one can use to it can give us using the generative AI can use to this information, getting misinformation from people. People can generate a lot of false information out there to defraud people, to to scare people, because the output from the generative AI is human like. You can actually differentiate it from the real images, audio, and so on. So it's very easy to give people false information using this kind of AI. Likewise, we have some examples of generative AI. We have OpenAI GPT, that's generative pre-trained transformer. It, it's basically used to generate tests that is closely human-like in terms of grammar, orange style. So it's very difficult to differentiate between the text generated and the real one, the input, like ChatGPT now. We have another one, Deep Art. This one is used by the is used for generating images, used in artwork, generating the various styles. Then we have a DALL-E. It was developed by OpenAI to generate image from textual description. When you supply text to this model, from the text you supply, it will generate model, it will generate images from it. The last one is Deep Dream. This one was developed by Google to generate images by modifying the existing ones using the algorithm called neural network. Now, in use cases, there are many places can leverage this. You can leverage generative artificial intelligence to achieve positive things. Like in finance, you can watch their transaction not to be better for detection. Like what I said now, in the unsupervised learning. Unsupervised learning is basically used for fraud detection because of what unsupervised learning bring out some hidden facts that was not known before. So you can use unsupervised learning in this case to detect fraud. Now, also, data firm can also use it to generate to design interpret their contract. You can supply any information you want to the child, to the model. This is what we want. This is what we to generate solution for them. So get argument, anything they want. Likewise, manufacturer can leverage on this to this is how they can do this one. They analyze, they gather some information about their parts. Let's say they are producing, let's say they are producing, let's say they are producing parts. They gather defective one and not defective one. They generate all the data, the feature, the images of the part. They generate it. They use it to train the model. So they can now use that model to predict the new data that they are giving to the model. It will generate, it will give them the root cause accurately and economically. A case scenario of this one is let's say scam scanner. Scam scanner. What they use on this one, they gather sensors of each part. Sensor, they use it to train the model. So it will be easier for them to generate output to make decision to get the root cause of the spectrum. The feature of the generative artificial intelligence, it's not the generative artificial intelligence. It can give betterment. It can give rise to betterment of grammar checker. What do I mean by the grammar checker? When train the model with a large volume of data sets, it is capable of producing a human-like test that is able to figure out the grammatical error in the sentence. Like for instance, if you supply any text to ChatGPT, ChatGPT will surely correct you. So the model has been well trained that is able to understand the grammatical and the syntax, semantics of each language. So it will be better for a grammar checker. Likewise, we have a design tools. Involvement of the design tools. The design tool, the train is capable. It's capable of bringing out design elements like image, graphics, and layout that has been trained on the model. So when you leverage on this, it will be easier for designer to design to to build out design in a very little and less energetic time. Therefore, designer can leverage on this to build out that design in a very short time without wasting much resources. It's very good for them. Also, we have a training tool. We build up the development of training tool. Online, like this training tool. When the learners, for instance, the student learner, they leverage of this generative AI. It will hate their learning by providing them with a conducive learning environment when they supply their exercise to the model, because the model has been well trained on how on the large data set of learning materials. Uh, when they supply data to the when they supply input to the model can easily bring out the solution. Let's say they supply input of let's say exercise. You want to solve this exercise. You want to learn this. This is what I want to learn. Then you supply the data to the model. The model can easily give them the conducive learning environment and give them the solution. So thank you for listening. I don't know. I'm ready to entertain any questions.
Oh, I'm very, very happy, Mr. Quadri Olalekan Ladejo. Ladejo. So please just, it's a mother's tongue. You should just pardon. Yeah. Thank you very much. You deserve an applaud. Like my say, very good explanation that you took your time. I'm so glad. I didn't even know you would give us this much. I'm very happy personally, and I thank you for having us giving us such detailed explanation of this particular topic, generative models. It's about time we move into questions and answers. I hope we've packaged our questions. Anyone that have been flying in the message, it's now time to speak their vocally, say it out. So please, it's time for questions and answers. You can start releasing our questions, please. Please, let's start. Questions, any question? It's a very interesting topic. A topic that even hearing the name, it's a new era, the new era thing with massive usefulness to us. Please, please. Sorry. Sorry. Please, let's start throwing our questions in. Please. Any question? Any question? The first speaker and Mr. Oladejo, they've talked about generative models, what generative models is. We talked about the types of generative model. We talked about the generative adversarial networks and the observational autoencoders. They've talked about the transformer-based models. I believe we were following through. If you have one or two to ask, then if we don't have any, is this a topic that should be bringing a lot of questions? Please, any questions? Please talk about the usefulness of the model generative AI that has come to be, and those are top leading. Those we call the giants. Support for developers, that's those goggles, the Microsoft OpenAI, even talk about the Azure cloud. And please, they've talked extensively on a lot. Please, let's just, there is none, then okay. Those ones that were flying on the this thing. Mr. Daniel Buildu. Mr. Daniel, are you here? Hello.
I am. I
Please,
am.
I am very interested in that topic, that particular one on the chat box. Just you may not really just one or within one less than 1 minute or so. If you have much time, no problem. But just give me something clear. I'd like to understand more on that very question my colleague talked about, deep faking. How
Um,
yeah.
Deepfakes. Deepfakes is just like represent like the article is sent out. I read on it, the article, and here like they kind of represented uh several persons from a particular company, financial company, and made videos of the workers in that particular company, those people. They all joined the meeting, all those workers joined the meeting. And so they were targeting a particular person. So that person actually thought, okay, since all these persons are here, they are also, this might be something true. According to the article, that he first of all thought it might be kind of scam or teaching stuff. But later, since he had seen his colleagues and even the representatives of those from other countries, he buy into the idea that it was all this because he had seen the people and their reactions and everything. So he cannot deny it since he has seen that. And at last, he sent out, according to this, 200 million Hong Kong dollar. That is equivalent to 25 million dollar US dollar. So that is what we pay for. People can use like use your identity, use your identity wrongly. It's
Okay.
anyone here.
This is beginning to yeah, I heard you, been hearing you. But at this point, it
Can
seems
anyone
the line
hear
seems to
me?
be in at this point, please. But the your explanation you give from
Can
the
anyone hear me?
I can hear you. I can hear you, Mr. Daniel. I can hear you. I can hear you. Mr. Daniel, I can hear you. Um, okay. Please, Mr. Caudry Ladejo, please, you talked about the we talked about generative being the topic. Then I hear you,
Yeah, I can hear you. Okay.
Mr. Caudry.
It's a relay.
Hello, Mr. Caudry, are you there?
Yes, I can hear you. I'm here.
At a point, I think I heard you start talking something that relates to this discriminative AI. Then you talk about the supervised learning and non-supervised learning. And if I may ask, please, what will you say is the difference between this generative AI and discriminative AI? I don't know if you know about it, but you need to mention something that delves towards that direction. I don't know. Please,
Yes, I got you. The discriminative,
just enlighten it?
discriminative, you
Yes,
mean the discriminative model and the
discriminative,
generative AI,
yes,
artificial
and
intelligence,
generative
the
AI.
difference between them.
Yes.
Actually, the difference between them is very glaring. The descriptive model, we are talking about descriptive model from the word descript, the description. So their function is to describe, I mean, to classify based on the input generated. Let's say we have a data in that data set. Let me say for instance, we have a email. You want to classify the email. You have email as one is spam, another one is not spam. So you want to use this model to generate a new data set to classify every input every email that was given to the project as spam and not spam. So in that case, that kind of model descriptive model. So we have other descriptive model. We have a regression. We have regression. That's a random forest regression. Let me go deeper. So let's just say the regression model. So those are the descriptive model. So their function is very limited, just to classify data without evidence there. So unlike this generative artificial model, its function is basically to generate
New.
content like text, images, audio, and video. So these are that- that's just the difference in them. You understand that?
Yes. Okay. Thank you for that. Thank you very much for your question and the questions you've answered. Thank you, Mr. Abiodo. Mr. Abiodo Daniel, you can drop your link if you wish to. Just link to your LinkedIn, and I believe one or two of us can have at some point or other have something or two to ask or know more about, because personally, as I will call you Prof, though despite the short notice you've been able to deliver, I would say thank you very much. So wrap up for today. Thank you all for being here. Thank you for attendance. Thank you, Mr. Hassan, for making it, for everything you've done. Bala Hassan, I say thank you very much. Thank you, Victoria. I can see you here. Team lead, Mr. Wisdom Idris. Thank you very much. Sharaf, thank you for being here. Mr. Kola Walela Dejo Kodri. Thank you very much, sir. All right.
Yeah, so we have community for techies, particularly as relating to this event, the software engineering community. So I actually dropped a WhatsApp link so you can join. The admin will let us in. If you're not on that channel on the WhatsApp group, it is good that you join, because going forward the group will be the one to be organizing such events and sourcing its own people too, and it allows us to interact. So the conversation is ongoing. You can continue in the group. Yeah, so you can join it in the chat box.
Okay. All right, let's do this. All right, thank you.